This is section 6.2 notes for whoever is gone today.
Hi,
like
Cody.
the FFA kids. Hi, Cody. Hi, Brooklyn. Whoever else. I don't know.
Cody, I didn't ask. Shut up, please.
Yeah. Okay. So,
Go, Roper.
2 things. 2 things before we start. Triangle sum theorem. All of the angles add up to be 180 degrees. That's something you learn in geometry class. That's going to be applicable here. So that's going to help you solve for things. So remember that all the angles add up to 180. You should know that already. If you don't, you're behind. Okay. Also, the Pythagorean theorem works for only right triangles. And for today's lesson, we're only going to be dealing with right triangles total. Okay. There's no funky weird triangles until we get to like the end of this chapter. Okay. But only right triangles, a squared plus b squared equals c squared applies. You can use it on today's stuff, okay? I'm going to go fast. Example 1, we are finding x, and that doesn't just mean, like, here it is. You find him. We're trying to solve for x, okay? This is going to involve some form of sine, cosine, tangent, but not all 3, okay? So, if it helps you and you need to write out SOHCAHTOA on the side, and then you will know what to do. Okay, so the first thing that you do when you're solving these problems is you look at the angle that you have, okay? The angle that I have here is 65 degrees, and then I need to look at the 2 sides that are given to me or that I'm trying to find and see what relationship they are to 65 degrees. So if I'm looking at 8, what is 8 in relationship to 65 degrees? 8 is the hypotenuse, okay? What is x? This is adjacent, okay? So, hypotenuse adjacent, I want to use a trig function. Which one am I going to use? Cosine, okay? Hypotenuse adjacent, that's cosine. AH, cosine. Cosine, and cosine of what? What goes inside of the cosine? 65 goes there, right? Equals, and I want to do them in the order that SOHCAHTOA is, okay? So it's A and then H. So which one goes on top? A, which is x. And on the bottom goes 8. And if I'm trying to get x by itself, I would multiply by 8.
Divide x.
X equals, okay? On your calculator, take 8 times the cosine of 65 and see what you get as an answer.
Wait, how do I turn my computer on?
3.38. I was going to say, it can't be bigger than 8 because 8 is the hypotenuse. 3.38. Yes? Yes? 3.38. Look to make sure that it's reasonable. Like I heard 8.38 come out of Sable's mouth. I didn't say that. I can't hear. I know you didn't say that. But that's what I heard. But I knew that 8.38 couldn't be the answer because the hypotenuse is 8. So make sure that these seem reasonable, right? Okay. So it just turns out I am deaf. I don't know. All right. Example 2. We are trying to solve for angle theta. Okay. Now they give me all 3 sides. They give me 3, 4, and 5. They give you so many things. This one you're just trying to measure angle theta. You don't have to solve for everything. They give me so many things. I only need 2 of the sides. Which 2 sides do you want to use? Just pick 2. We don't care.
Opposite
Okay, 3 and 5. That's the one that we want to use. We want to use opposite hypotenuse. Sure. We only need 2 of them. We get to choose. If you choose a different one, you will still get the right answer. You'll just use a different trig function. So they want to use opposite hypotenuse, which means we're using sine. Okay, this is going to be a little bit different, all right? A little bit tricky. You have to do one more extra step on your calculator, all right? Sine. What are we taking sine of? Theta. Sine of angle theta, okay? We don't know the angle for once, okay? We don't know the angle. Sine of angle theta equals opposite of our hypotenuse, so we do 3 over 5. Okay, now, how do I get angle theta out of there? You do the inverse, okay? Some of you guys remember this? I think we did this in geometry, maybe. Yeah, you did this in physics, okay? So, inverse sine cancels it out, so basically theta is equal to inverse sine of 3 over 5. Okay, so on your calculator, that is the second sine. Second sine 3 over 5, type it in, see what you get. How many degrees? 36.9. We'll do 1 decimal. 36.9 degrees. Done.
I have a question.
Yes, ma'am.
6, 9, minus 3.
You what?
Maybe that's all you need.
Okay. So we could have chosen to use 4.
Yeah, that's
we
what I
chose
meant.
not to use 4. Okay. We chose not to use 4 Liddell, right? 5 is the hypotenuse to angle theta. So in that case, we would use cosine. We did bring it up. Yep. So if we wanted to use the 4 instead, we'd use a different trig function, but it would give us the same answer. Yeah?
Yeah.
Good, good? Okay, keep going. All right, now, this is the ugly part. This is the part that Wynn's been whining about the whole time.
Have you done this in
done
physics?
It says, example 3,
What did I whine about?
solve the triangle.
Oh my God! Stop
Have you done this
whining.
in physics?
Okay. When it says solve the triangle, what am I solving for on the triangle?
Guess what?
In theta. In
You
theta.
are solving for everything that's not already there.
In theta.
Everything that's not already there. So, let's see. This is A, this is B. I'm going to make these bigger. A, B, let's call this guy C, and he is 17. We know that for sure. Which angle is angle A then? The opposite one. Opposite of A, so 75 is the angle A, right? Okay, angle B is the top one here. Angle C is the right angle. Do you guys see how we did that? Okay, angles are always labeled with capital letters. Sides are always labeled with lowercase letters. So I'm going to go over here, and this just helps me a little bit. A, B, C, A, B, C. Okay? 3 of those things we already know. 3 of the things that we don't know. And then you have to solve for all of the remaining things. Okay? So I just put them over here, even if we're given that stuff already. We know little c. Little c is 17. We know capital A is 75, and we know capital C is 90 degrees. Okay? Which one is really, really easy to solve for now? Capital B. Can we solve for capital B really easy? Yes, because they have to add up to be
180.
180. 90, 75 has to add up to be 180 with angle B. So what's angle B? 15. Okay, so I know that for sure. This is one of the things that we've solved for. B is 15. Okay? Now, we need to either solve for A or B now. Which one do you want to do first?
B.
You want to do B first? Sure, we'll be weird. Let's do B first. So we're going to solve for this B. Shut it off. Okay,
Well, there's a
B.
man stuck in the Lego River.
We don't care. You can go to the office and watch it. You want to go to the office and watch it? Well, that's what I thought. Don't do that. Let's solve for B first. Okay, so the angle that I'm given is 75 degrees. Let's just continue to use him, but we want to use angle B, and then we want to use the 17, because the 17 is the other thing that I have labeled. Yeah? Okay, so in relationship to 75, what is angle B?
Adjacent.
It is the adjacent side B, side B. Is adjacent side C? Hypotenuse, so which trig function? A and H. Cosine. So we're going to do cosine of 75 equals B over 17, right? A over H, B over 17. Okay, move the 17 to the other side. What's 17 cosine of 75? B equals 4.40. B is 4.40. That's another one that we've solved for. Okay? Do at least one decimal place. At least one decimal place. A, then. How do we solve for A?
Oh, we can just use A squared plus B squared equals C
We
squared.
could use the Pythagorean theorem.
So,
Let's
so
go
it's so.
ahead. No, just wait. We could use the Pythagorean theorem, but because 4.40 has been rounded, let's do another trig function just to get, it's the same amount of work. Let's do another trig function to find A, because then he won't be a rounded number, okay? So, we'll use the same numbers again. We'll use 75, but this time we're going to do A and C, okay? Could you use A and B, since we know what B is now? Yes, but why not? Because B is rounded. So you always want to use what they give you to start with, if at all possible, okay? So we could use A and B and do like tangent or something, but let's use the C originally that they have, okay? So A is going to be opposite. C is still hypotenuse. Opposite hypotenuse is sine. Sine of 75 equals A over 17. Okay, same steps again. Multiply by 17. What is that? 16.42. Now, that guy should be, which side should be the longest side?
C.
C should be the longest side. Is it the longest side? Yes, it is still, right?
I'm just saying. Nobody asked.
Why is one of my sides 16 and one of my sides 4?
Because one's shorter than the other.
Look at the angles. A 15-degree angle versus a 75-degree angle, okay? Those should also go in relationship to each other. So the biggest angle should have the biggest side. The medium angle should have the medium side. The small angle should have the small side, yeah? Okay, beautiful. All right, solve the triangle in the figure. Okay, so they give me some of the stuff. We have to solve the other stuff.
Is that B thing called beta?
That is called beta. You are right. You are right. Okay. All right. Which one do you want to solve first? Which one do you want to solve first? Let's solve for A first. Little A. Let's solve little a first. Okay. How do you solve little a? Pythagorean theorem. Okay. So a squared plus which one? 6 squared equals
1 away.
12 squared. A squared plus 36 equals 144. You should do some of those in your head. Minus 36. A squared equals like, is that what you said, 108?
Yeah.
Take the square root. Give me one decimal.
10.4.
10.4. 10.4.
Yep.
10.4. Okay, there he is.
Mm-hmm.
Okay. All right. Which one do you solve for next? Theta or beta?
Beta.
What?
Beta.
Theta? Sure. So this guy up here. Okay. Which two sides do you want to use?
Opposite and hypotenuse.
We always want to use the two that the ones that we didn't round, if at all possible, right? So we're going to do 6 and 12, okay? So 6 is opposite, 12 is hypotenuse. Just like Holly said. Opposite hypotenuse. So theta, which trig function? Sine of theta equals 6 over 12, which is 1/2. And you do the inverse. And if you do the inverse, you find that it is it 30 degrees?
Yes.
Yeah, because sine of 1/2 is 30 degrees if you look on your unit circle.
60.
Oh my. 30 degrees. Now, you could have used another trig function to find what beta is, but don't do that. Right? They add it to be 180, so this has to be 60 degrees. Beautiful. There you go. All done. Okay? When it says solve the triangle, find everything that's missing. Whatever. Okay? You follow all that? It was kind of fast. Yeah? This is stuff you should have already done before. And should know already for, I don't know, we'll see. And should already know for your, for the ACT. ACT will do this stuff. ACT will do this stuff to you. Yes, okay? All right, the rest of this is story problems. We're going to maybe do a couple of these. We'll skip some. Okay? All right, example 5. A straight road leads from an ocean beach at a constant upward angle of 3 degrees. Do you see where they've labeled 3 degrees on the diagram? 3 degrees is this bottom really tiny angle right there. How high above sea level is the road at 1 mile from the beach? Okay, they have changed 1 mile to be feet, 5280. What? Yeah, but it's going to be, they want it in feet. So we'll leave it in feet. Okay, so they want to know height. They give me this. Okay, in relationship to the 3 degrees, what is h? Opposite and hypotenuse. So which trig function? Sine of 3 equals h over 5280 or x, whatever you want to call them. Okay, multiply by the 5280. 276.33 feet. That's how high it is above sea level. Not very high, right? They converted that to feet because if we would have left it in miles, it would have been like 0.00 something, right? Or 0.0 something. Really small. All right, next one. I'm going fast. Ladder safety. According to this safety sticker on a 20-foot ladder. 20-foot ladder. This is a building right over here. And my ladder goes this way. There's my ladder. 20-foot ladder. They've labeled the ladder with 20 feet there. The wall we're assuming is perpendicular with the ground. If not, we have bigger problems than what we're trying to solve. Because that would mean our building was leaning. But this is a right triangle because we're assuming that it's perpendicular. So, From the bottom of the ladder to the base, we're trying to find the angle, and it's 5 feet from the bottom of the base of the triangle, so we have to try to find theta. Okay, so we're looking at theta. What is 5 and what is 20? What's 5 and what's 20? Adjacent hypotenuse, so we're going to use cosine of theta equals 5 over 20. Really, if you want to reduce that, that would be 1/4, right? Inverse cosine.
Well, this is easy now. Look.
Okay. What did you say?
Oh wait, 75.52.
We'll go 75.5 degrees. That was part B. We solved part B first. They want to know how high up the wall the ladder will reach.
So,
How do I find H? I would do the Pythagorean theorem because if we use the angle was rounded, right? We want to use the stuff that's not rounded. So I would do the Pythagorean theorem first. 5 squared plus h squared equals 20 squared. Whatever. 25, h squared, 400, h squared equals 375. H is 19.36 what?
Feet.
Feet. Feet high. Yeah?
Feet degrees.
What?
Mrs. K, he's got a point.
It's not in degrees. That's not in degrees. You would have to convert 1966.
Erica, your hair looks good.
Whatever. Don't listen to that. Don't listen to that. 19.36 feet. That's a T. I know, because this thing is hanging over on the side. Whatever. Feet. Feet. Okay? All right. Okay, take a look at depression. Yeah. Take a look at this little diagram. If they don't give you a picture, listen. If they don't give you a picture but say it's an angle of elevation and an angle of depression, think of it from the horizontal. So if I have my arm straight out in front of me and I want to elevate my arm, that's going to be the angle of elevation from here to here.
Yeah.
If I'm depressing my arm or an angle of depression, it's going to be from here down. So this guy right here. Put that away with the L. Okay. So angle of depression goes down, angle of elevation goes up. This is what they look like. Here and here. Okay? They will not always give you a picture. Yeah? They will not always give you a picture. Okay. Let's skip 7.
Why?
Let's go to number, 8.
There's 2 8s.
Oh, there are 2 8s. I'm trying to figure out one where you have to switch the bottoms around, and it's not. How long should the wire be? Yes, we're gonna do the top 8. Yeah, we're gonna do the top 8. Okay, top 8 here. This is in feet. Is this in feet? Meters. 10 meters. Okay, this is 10 meters. What's this angle right here?
90.
No,
Wait, are you saying an A for A?
that's like little alpha. That's an alpha. Alpha.
Are you asking for A?
Yeah.
It's 68.
How do you know it's 68?
Because you subtract 22 from 90.
Right. 90 minus
So you get
22
negative
is 68. Beautiful.
And then you switch around and you make
Okay.
it positive. And now it's 68.
They want to know how long the wire is. So they want this guy. So we have a triangle right here. We're trying to find this. 68 and 10 is here. Okay. So 68 is my angle. What's 10? Adjacent. And this guy is the hypotenuse. Okay. So which trig function? Cosine 68 equals 10 over h or whatever we're solving for. Okay, now this one is different. Yes, this one is different than what we've done before. Before we had the h on the top and the 10 on the bottom, we just multiply the 10 over to the other side. But when you're doing this and you're solving for h, this is on the bottom here. I think we've done ones like this before where you just take these two guys and you flip them around, right? Right. Yeah, yeah. Because what would eventually happen is if I'm trying to solve for h, I would multiply the h over, right? H times cosine of 68. But then I would divide by the cosine, so h is equal to 10 over cosine 68, yeah? Okay, which is how many? 26.7 meters. There it is. Good, good?
Yeah.
Great.
That was
Great. Great. Is this one different?
Okay, on to 8-2.
On to the second 8.
No, 8-2.
8-2. This is a good one. 8%. This is a good one. A person on the edge of a canal observes a lamp post on the other side with an angle of elevation. I don't know how they know it's a 12-degree angle of elevation by looking at it, but whatever. We're just going to go along with it. The angle of elevation is 12 degrees. The angle of depression is 7 degrees to the bottom of the lamp post. Find the width of the canal. What does that mean?
They want to know what is the length from the dude to the pole.
They want to know the length from the dude to the pole. So they want to know this guy right here. They want to know that length. Okay? Now, which triangle are you going to use to find that? The top triangle or the bottom triangle? Shh. The bottom triangle, I know from here to here is how big? What's this side?
152.
152, because it's the same as what he is over there, right? Aha, aha. So I'm looking at this bottom triangle right here. If I make him, I'll draw him out over here.
Actually, that's not. That's 152 is the total of the person can learn from his eyeballs, so technically that's the last thing.
But it says the person's eye level is at 5 foot. That's what it says up here. The person's eye level is 152. They're not going from the top of his head. They are definitely going from his eyeball. Okay. So 7 degrees. They want to know this and 152. Okay. We're trying to find the horizontal distance, which is that x. Okay. So that's what we're solving for in part A. Find the width of the canal. All right. Opposite, and that's not hypotenuse.
Oh, it's not.
It's adjacent. Adjacent and opposite. Which trig function? Yeah, we haven't used tangent yet.
That's a first.
That's a first. Equals 152 over x. Then flip those two around. So x is going to be equal to 152 over tangent 7. And that is in, centimeters. Isn't it? So that would be like what? Is there 100 centimeters in a meter? Yeah. So it'd be 12.379 meters. Whatever. If you want to switch to meters, that's fine. Whatever. Okay. Find the height of the lamp post. Okay. We know that from here to here is 152. So basically we need to find from here to here. Okay, which means we need to use the top triangle, which looks like this guy. Okay, we have 12, and we need to know this thing. Okay, what else do we know?
There's a 90 degree.
We know that there's a 90 degree right here. What else do we know?
The other angle.
Nope. Well, we don't care.
78.
No, we just found the.
No, in the other angle, 78.
That
So-
side, that bottom side is 1237.9.
Nobody cares.
We don't care about that other angle. We know that this bottom side is 1237.9. Now, in this one, it is unavoidable. We're going to have to use that rounded number that we use. We just can't avoid it, okay? We have to use it, okay? So we have 12 degrees. X is what?
That is opposite.
Opposite. This one is
Adjacent.
adjacent, so we're having to use tangent of 12 equals x over the big number. Okay, and then we swap those two around, so x equals, oh no, we don't switch them around, times 1237.9, I can't think.
Yeah, I'd say.
263.
263 point what?
1.
0.1? That's all that top is? Huh.
I took the exact rounded number.
Oh, the non-rounded number. Okay.
But you gotta add it up.
Oh, so it's not 263.1 is the answer? Yep. So that's in centimeters, but the bottom one is in centimeters also, right? And our distance here was in centimeters, so we're good to go, right?
Yep.
So the whole lamppost is whatever that is plus 152.
415.1.
415.1,
Yep.
and that is in centimeters. That's how tall my lamppost is. Okay? That would be 4.151 meters tall, if you want to think about it in terms of that. Does that seem like a reasonable lamppost?
Yeah, I
Probably
get it.
4 meters tall. Yeah, that's like 12 feet. A little
That's
over 12
on
feet.
the
Homework. Okay, there you go. Homework's on the board. I'll post it on my Google Classroom where I post this video. There you go.